Go ahead and graph the tangent functions. Tangent, as you can see here, is a picture here, but the graph is completely different than our sine and cosine graphs we worked with in the past couple days. Starting out with here, tangent has what we call asymptote lines. And I'll put in a dotted line over here on the left-hand side, represent the asymptote line on the left side. That asymptote line occurs at negative pi over 2. On the right-hand side, I have another dotted line I'll label as an asymptote line. And that dotted line is at pi over 2. What those asymptote line means is our graph will continue to approach and get closer and closer to those asymptote lines, but never cross or never touch. So tangent is undefined at those points. So if you were to type into your calculator the tangent of pi over 2 or the tangent of 90 degrees, you get an undefined answer because the denominator is 0. Same thing with negative pi over 2, and you can see down here at the bottom, negative pi over 2, pi, 3 pi over 2, 5 pi over 2, and so on. Tangent will be undefined. Moving back here on this side, we have another critical point, which is at negative pi over 4. The y-coordinate there is 1. We have the midpoint here at the origin, 0, 0. And we have another critical point over here at pi over 4 and positive 1. So those are the same, are 5 critical points for our tangent curve, much like we had 0, pi over 2, pi, 3 pi over 2, and 2 pi for sine and cosine. Obviously, the shape is completely different. We have the asymptote lines in there, so this will be referred to as a left asymptote line or the starting point, right asymptote line or the ending point with our quarter, mid, and three-quarter points in between. Scrolling down here, you can see those lines written in here. Our quarter point and our three-quarter point will tell us if any kind of amplitude changes. So if this value changes from negative 1 or positive 1, that's where you'll have an amplitude that's different. That's the only way to really recognize the amplitude, at least for now. So if this was a negative 2 and a 2, then our amplitude is obviously 2, and so forth. If it's 4 or negative 4, then the amplitude is 4. Other than that, the same information applies to tangent that we worked with sine and cosine as far as finding critical points and A, B, C, and K, except right here. Our period length, if you'll notice back up here on our graph, goes from negative pi over 2 to positive pi over 2, which is pi units long. So period length is found by taking pi and divided by b. If we recall from sine and cosine, that was 2 pi divided by b. So we have a different equation or formula there to find our period length. But past that, k is our vertical translation, a is our amplitude, b affects our period length, and c is that shifting the graph right or left along the x-axis. Cotangent, very similar looking graph, but obviously different. We'll start out here drawing a dotted line right on top of the y-axis, and that is at x equals 0. That is the right asymptote, or right, how about the left asymptote line for cotangent? So our left asymptote line, or that might be our starting point, is here at the y-axis. We have a quarter point here at pi over 4 and 1. We have a midpoint crossing at pi over 2 and 0. That's our midpoint. And then over here we have a three-quarter point at 3 pi over 4 and negative 1. And much like our tangent curve, we have an asymptote line on the right-hand side at pi. Again, right asymptote line could also be referred to sometimes as an endpoint. Pretty much the same idea. Our asymptote lines where cotangent is undefined. Our graph gets closer and closer to those lines but never touches. So it continues on up and on down, noting that our cotangent graph goes down from left to right, where our tangent graph goes up from left to right. Other than that, things identical. Here's our left asymptote line again, x equals 0. Quarter point at pi over 4, midpoint pi over 2, three-quarter point 3 pi over 4, and right asymptote line at pi. There's our k, our a, b, and c, same values. Again, noting our period length for cotangent is also pi divided by b. You can see that by the fact that we go from 0 to pi up here. So period length is pi. Tangent and cotangent both use pi divided by b, whereas sine and cosine use 2 pi divided by b. That will get us into graphing here. Graph over a 1 period interval, cotangent of 1/2 x. Again, a new set of critical points to know. Our cotangent does start at 0, so I multiply both sides by 2. X still equals 0. That will be our left asymptote line. Starting over 1/2 x, our quarter point occurs at pi over 4. So I'll multiply by 2, and x will equal pi divided by 2 for our quarter point. And no different than the work that we did with sine and cosine. We'll go ahead and find a third point. Midpoint is at pi over 2. Multiply both sides by 2, and x equals pi for our midpoint. Those points, 0, I'm going to rewrite the pi to be 2 pi over 2. That way you have the same denominator through here. That way we can see the next point is at 3 pi over 2, and our last point is at 4 pi over 2. And we'll go ahead and sketch that graph. Zero, pi over 2, pi, 3 pi over 2, and 2 pi. We'll go ahead and start with our asymptote lines right here and right here. Noting that our cotangent up here has a amplitude of 1, so I'll just mark 1 and -1 on here. That will help me with the sketching of my graph. I'm simply going to make a point here at our quarter point. It crosses the x-axis at a midpoint, and at -1 here. I'm going to use those three along with our asymptote lines to sketch in our cotangent curve for 1 period. And there it is, going down from left to right, amplitude of 1, crossing the x-axis at a midpoint, and our 3/4 point. We move on, y equals tangent of x plus pi over 3. We'll have a little bit of shifting going on here, so x plus pi over 3. The left asymptote line for tangent is at -pi over 2. I'll solve for x by subtracting pi over 3 from both sides, which means I have to have a common denominator of 6, so this would be -3 pi over 6. This would be -2 pi over 6. So x equals -5 pi over 6 is our left asymptote line, or where we're going to start our graph from. I'll repeat the process. So x plus pi over 3 equals -pi over 4 for our quarter point. Subtracting pi over 3 from both sides. Again, common denominators. This time it's going to be 12. And that will be -3 pi over 12 and -4 pi over 12. X is -7 pi over 12. And just to verify that our algebra and our math is correct, x plus pi over 3, I'll set equal to midpoint, which occurs at 0. Subtract pi over 3, and this time it's much easier. X equals -pi over 3 is our midpoint. Going back here, quarter point, left asymptote. If you look at those three, they would have a common denominator of 12, so I'll rewrite -5 pi over 12 over 6 to be -10 pi over 12, -7 pi over 12, and then -4 pi over 12. I hope then it becomes pretty obvious to us we're adding 3 to our numerator, so I'll have -1 pi over 12 and 2 pi over 12 as my other two critical points if I'm going to graph 1 period, which we'll go ahead and do now. Making our x and y axis here. We'll kind of work backwards here. -pi over 12. Let's try that again. Negative is not going to be on this side. So let's start over. -pi over 12 on this side. -4 pi over 12, which is -pi over 3. -7 pi over 12. And we need one more point, -5 pi over 6. And we do have our positive point at pi over 6. Our first point is our left asymptote line. Our last point is our right asymptote line. Kind of backtracking just a little bit here, you can see we have an amplitude of 1, so I needed to mark that on the graph as well, 1 and negative 1. And then I'll use that along with my quarter, mid, and 3/4 points to plot or sketch the tangent curve. Will look something like that. Again, tangent goes up from left to right. Let's try again here. 3 periods this time of the cotangent of 2x. Let's zip through this one fairly quickly. 2x equals 0. That's our starting point, or our left asymptote line. So x equals 0, left asymptote line. 2x equals pi over 4. We'll divide by 2, which is multiplying by a half, and x equals pi over 8 for our quarter point. And we'll go one more time here to verify our results. Our midpoint's at pi over 2, divide by 2, which is multiplying by a half, and x equals pi over 4 for our midpoint. Rewriting those, we have 0, pi over 8, 2 pi over 8. So it should be fairly obvious that we're going to add, and I need to have a whole slew of terms here, so I'm just going to start writing to get our 3 periods worth. Keeping in mind, if we wanted to go back to the negative side, we probably could. I'm just going to do all positive ones for now. You've seen in our homework that we can go back the opposite direction. And all the way up to 12 pi over 8. That should get us enough critical points to go ahead and graph. We'll go ahead and try and squeeze this on here. Three periods. Let me go back here. What was our amplitude? Our amplitude is still 1. So I'll mark that on here, 1 and negative 1. And then we'll put all these critical points on here. Pi over 8. Pi over 4, 3 pi over 8, 4 pi over 8 is pi over 2, 5 pi over 8, 6 pi over 8 is 3 pi over 4, 7 pi over 8, 8 pi over 8 is just pi, 9 pi over 8, 10 pi over 8 is 5 pi over 4, 11 pi over 8, and 3 pi over 2. Sketching in. Our left asymptote line is there at 0. I'll just count them out. Quarter, mid, 3/4. So the end of 1 is there. Quarter, mid, 3/4 end. There's another end. Quarter, mid, 3/4, and end right there. So there's our 3 periods. Our cotangent graph goes down from left to right. I'm just going to plot those points going down from left to right and sketch in all 3 periods of our cotangent curve. So as you're pointing out, number 1, it's very, very similar to our sine and cosine procedures anyway. Obviously the graphs look different and they have different critical points, which you're going to keep track, hopefully be able to keep track of. I think we have one more here. We'll go with the tangent curve, or we'll graph 2 periods of 1 plus 2 tangent of 2x plus pi over 6. And let's start out by finding our critical points. 2x plus pi over 6, we're finding a left asymptote line which occurs at negative pi over 2 for tangent. I'll subtract pi over 6 from both sides. I need a common denominator, which is going to be 6. So I have negative 3 pi over 6 minus pi over 6, which is negative 4 pi over 6. Negative 4 pi over 6 simplifies to be negative 2 pi over 3. I'll divide by 2, which is multiplying by a half, and x equals negative pi over 3 for our left asymptote line. We'll go ahead and repeat the process again to find our quarter point. Our quarter point for tangent occurs at negative pi over 4. We'll subtract pi over 6 from both sides. You can see here, once again, we need a common denominator. In this case, it would be 12. So it'll be negative 2 pi over 12, and this will be negative 3 pi over 12. So 2x equals negative 5 pi over 12. Divide by 2, multiply by a half, and x equals negative 5 pi over 24. One more time, especially because we have so much algebra there, that we'll go ahead and check our answer, our incremental values. 2x plus pi over 6 equals 0, so 2x equals negative pi over 6, divide by 2, multiply by a half, and x equals negative pi over 12 for our points. You can see between these three we have a common denominator of 12, so I have negative 4 pi over 12. Oops, let's try that again. Common denominator of not 12, how about 24? So I'm going to go negative 8 pi over 24. Negative 5 pi over 24. And over here, multiplying that by 2, I get negative 2 pi over 24, which hopefully sees that we're adding 3 to our numerator. So I have a positive 1 pi over 24, 4 pi over 24, 7 pi over 24, going for 2 full periods, 1, 2, 3, 4, 5, 6. So I need 3 more, 10 pi over 24, 13 pi over 24, and 16 pi over 24. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have all 9 terms there. So we'll go ahead and use those to sketch our tangent curve. And going across, negative pi over 12, negative 5 pi over 24, and negative pi over 3. On this side, I have pi over 24. 4 pi over 24 is pi over 6. 7 pi over 24. 10 pi over 24 is 5 pi over 12. 13 pi over 24, and finally 2 pi over 3. Sketching in our asymptote lines. There's 1, quarter, mid, 3/4 end. Quarter, mid, 3/4, and end. Tangent goes up to right, from left to right. I need to backtrack here. It looks like we had an amplitude here of 2, so we'll start with that. I'll mark 1, 2 on there, 1, 2. I'm going to plot my points and come back to that vertical translation. Okay, we see that we have a 1 here, so I'm just going to cover that up for now and graph what we have here, and then we'll make that adjustment once we're done. So I go, tangent goes up from left to right, so here, here, and here, and then 3 more for our next period. That's when we'll bring that vertical translation back into play. We're adding 1, so we're going to move each of those points up by 2 units, or by 1 unit. So instead of being at negative 2, we'll be at negative 1, 1, and I'll just mark 3 on here so we can go up, up 1, and up 1. We're actually going to connect those points for our graph of y equals a tangent, or 1 plus a tangent of 2 times x plus pi over 6. And there we go. I guess we've got one more here. We're going to zip through this. 1/2 x plus pi over 6 equals negative pi over 2. Subtract pi over 6. Common denominator is 6, so negative 3 pi over 6 minus pi over 6. 1/2 x equals negative 4 pi over 6, which is negative 2 pi over 3. Multiply both sides by 2, and x equals negative 4 pi over 3. Let's go a second time. 1/2 x plus pi over 6 equals negative pi over 4. Subtract pi over 6 from both sides. Common denominators again. That's going to be 12. So let's go with negative 3 pi over 12 minus 2 pi over 12. So 1/2 x equals negative 5 pi over 12. Multiply both sides by 2, and x equals negative 5 pi over 6. And one more time here. 1/2 x plus pi over 6 equals 0. 1/2 x equals negative pi over 6 multiplied by 2, and x equals negative pi over 3. So let's take those points and find our incremental values. Common denominator is 6, so I have negative 8 pi over 6, negative 5 pi over 6, and negative 2 pi over 6. See, we're adding 3, so we'll go to a positive pi over 6, 4 pi over 6, 7 pi over 6, 10 pi over 6, 13 pi over 6, 1, 2, 3, 4, 5, 6, 7, 8. I need one more to get my 2 periods worth. Paying attention here, I have a negative amplitude and I have a vertical translation of 2. So let's start with our points here. So an amplitude of 1. We have negative pi over 3, pi over 6 on this side, negative 5 pi over 6, and negative 4 pi over 3. 2 pi over 3 here, 7 pi over 6 here, 5 pi over 3, simplifying the 10 pi over 6. Let's try and fix that just a little bit. 5 pi over 3, 13 pi over 6, and one more is 8 pi over 3. Asymptote lines go in over here on the left-hand side, quarter, mid, 3/4, and end. Quarter, mid, 3/4, and one more. Now this time we are graphing tangent, but it's a negative tangent, so it's reflection. So it's going to go down from left to right, basically looking a lot like a cotangent graph. And then we have that vertical translation. See if I can't get it back in play here. A vertical translation of up 2. I'm going to mark that on my axis here, 2 and 3, and just shift each of those points up. Instead of being at 1, we'll be at 3. Instead of being at 0, we'll be at 2. Instead of being at negative 1, we'll be a positive 1. So it's going to move our entire graph up 2 units. And there is our sketch of the tangent curve. And that should get us through tangent and cotangent.